Hi everyone, welcome back to another Pre-Calculus 12 Trigonometry video. We are finally finishing 6.3 in this video, so it's 6.3 part 2, trig functions, and so the good news is there's nothing new. It's kind of just carrying on with what I taught you in the previous two videos. So just to remind you, we did the quadrantal angles and then we did the special triangles. And so what we're doing right now is basically just a continuation of that. So let's just dive right into some examples. The first one says determine the exact value. And reminder, we are not using calculators for these. And exact value means don't turn it into a decimal. We want to leave it as a fraction. So if, for example, in the first one, actually I think I might only have one, it's tan of negative 19 pi over 6. Okay, so we want to figure out what exactly or precisely this is equal to. And there's a bunch of different ways we can do this. As always, I'm going to try to choose the scaffolded step-by-step method that will make things easy for you to follow along with and understand. And I think the first thing is wrapping our head around like where this would fit on a unit circle or what the reference angle would be, whatever you find helpful or useful in doing that. But I think that a good way to do this is, first of all, I noticed that this is a negative. Sorry, I'm not gonna do it there. I'm gonna do this below. So I noticed that it's a negative, so I would like to unwind it to pull it back into like the positive side of things. So, and then the other thing is, if I'm going around, I would want to look at a full rotation. Like a full rotation, we've talked about this before, is 2 pi, but I want to find what that is the same thing as a fraction over 6. So I'm going to make this a bit thinner so it's better for you to see. If it's a fraction over 6, well, this is like saying 2 pi over 1, which we would never really write, but I would multiply by 6 to get that denominator. So I'm also going to multiply that by 6. So this is the same thing as 12 pi over 6. That's the first thing that I like to do so that I can start to think in terms of the fraction or the denominator that's given to me in the question. But it's the same thing as 2 pi. It's just really helpful to be able to convert things to the same terms that the original question is in. So if I want to take this negative 19 pi and I want to unravel it, or I want to find the reference angle, then a good way for me to do that is to take that negative 19 pi over 6, and I would want to add 12 pi over 6 to start to unravel it and start to bring it to the positive side. But just by looking at it, I can tell like doing that once is not going to help me. I'm going to have to do it again. So instead of doing plus 12 pi over 6 again, I'm just going to multiply that by 2. So basically we're just doing this negative 19 pi over 6 plus 24 pi over 6 to put things into perspective. So if I have negative 19 and I add 24 to it, I am going to get 5 pi over 6. This is my angle in standard position. Just to remind you, standard position means it's between 0 and 2 pi. So it's in the positive side of things, and we've unraveled it to figure out whereabouts that would be. So the next thing is, again, I'm trying to wrap my head around this. If I'm going like that 0, that would be like pi over 2. But if I want to do this over 6, well, I don't need to do this over 6, so we're not going to. So I could say that's pi over 2. I could convert it to a fraction over 6. I could say 3 pi over 6. And then here would be pi, but if I'm trying to think of this stuff in terms of like a fraction over 6, do you see that this is the same thing as thinking 6 pi over 6? So these are not things you actually have to write down, But if you struggle with fractions, thinking of them in your head, do write this down, because I find in this unit, I've learned this over years of marking this stuff, that it's not the trig that's throwing people off, it's the fractions. So do whatever you need to do to practice with your fractions and wrap your head around this, but I think that's a helpful way to do this. Pi is the same thing as 6 pi over 6. Already by doing that, I can tell that this must mean that my solution, or what I'm working with, is obviously in quadrant 2. So I'm just doing this to wrap my head around like where this is, what to do with it, and all of that type of stuff. Okay, so then the reason that I'm doing that also is like the all students take calculus. If I'm looking for tangent, I know that here sine is the only one that's positive, so I know my answer is going to be negative here. So as you can see, I do apologize, this is a big ugly mess. This all went together, and then the other stuff was just me thinking and splatting it on the page, and it's not very neat and tidy. So if it's okay with you, I want to get rid of this. We decided that this must be in quadrant 2. So that's helpful for us to know. It's in quadrant 2. Therefore, the answer is negative. Good for us to know and to keep in mind. I could draw it in quadrant 2, or I could just get down to the special angle stuff to help me to figure out what to do with this. Because if it's 5 pi over 6, let's say I make this 5 pi over 6, and here is 6 pi over 6, do you guys see that the reference angle, or the angle in here, must be pi over 6? So to be very clear, this 5 pi over 6 is our standard position angle. So that's this part here. That's not a reference angle. Remember, a reference angle has to be acute. So it has to be like between 0 and pi over 2, or between 0 and 90 degrees. So that's how I know that I do 6 pi over 6 minus 5 pi over 6 to find that the inside is actually pi over 6. So moving this along, I recognize that pi over 6, well, that's from that, I'm going to redraw it here. Like, remember the quadrilateral triangle that I chopped in half? So when we chopped that in half, this was 1, 2, and this is the 3 with a root sign on top, so that you can quickly wrap your head around how to think of this. And then the bottom angle was still the 60 degrees, so that's going to be pi over 3. And the top one is the one that we chopped in half, so that's the pi over 6. So that angle up top is the one that we're going to use to figure out what tangent would be equal to. So I could say here, tan of pi over 6. I know I want my answer to be negative because we talked about how it's in the second quadrant here. So tan would be opposite over adjacent. So opposite to that would be 1, and adjacent to that would be root 3. So negative 1 over root 3 is what we get, but we don't like this because there's a radical in the denominator. So I would multiply by root 3 over root 3 in order to rationalize the denominator. So after all that, I get negative root 3 over the number 3 is my answer to this whole question. So to remind you, after all the stuff that we just went through, I used this second quadrant stuff to help me to figure out if the answer is going to be positive or negative. But I could have drawn this special triangle into that second quadrant, but I'd have to adjust things and rearrange it. So I personally find it easier to use this to figure out if the answer is going to be positive or negative using the all students take calculus approach. And then once I know that, I like to draw out my special triangle like this way to really get a clear sense of what the ratio would be. Okay, so I hope that is helpful. Okay, let's try another example that's similar. So let's say it says find the smallest positive theta in degree and exact radian measure. Okay, so if for the first one, we have sine of theta equals negative root 3 over 2. So we almost always do this. We're kind of doing the opposite of what we just finished doing. And we talked about how that is helpful because to go forwards and to learn a scale and then to go backwards is what really pulls it all together and gets you to understand it in a deeper way. So there's different ways of going through this. I'm going to talk you through what I think is the easiest approach to simplify things. I'm using the same thought process as in the last one. So I look at this and I think, okay, first of all, it says find the smallest positive theta. That's kind of like a hint or a clue as to what to do with this. Sine theta is negative. Like remember, all students take calculus. So if sine theta is equal to a negative answer, then that tells me that I must be dealing with this or this. So I'm going to take those two out of there. It's not going to be there. I'm either dealing with quadrant 3 or quadrant 4. Then it says find the smallest positive. So obviously the smallest positive is going to be there. So that's how I know I'm going to narrow it down to quadrant 3. So find the smallest positive theta because I'd be going around in this way. So obviously quadrant 3 comes first when we're going in our counterclockwise direction. So that's how I know that this is the quadrant that I'm working with. There's my first step. Then the other thing that I do is I think, okay, sine of theta is equal to opposite over hypotenuse. So my opposite must be negative root 3, and my hypotenuse must be 2. Which makes sense because if I think about it, if I were to draw this out here, if that's my theta, opposite to that would be negative because it's the y value. And the hypotenuse, of course, it's going to be positive. We know that it always is. So this is, again, helping me to figure out where I am and what's going on here. Okay, and then the other thing is I look at this and think, 2 and root 3, that looks like some of the special angles that we've been working with. So I'm going to draw, it says to give it in degree and radian measure. Let's think in degrees because that's what you're most familiar with. Again, just to remind you, and I hope by me repeating this over and over again that it's really starting to stick. But remember that taking half of that equilateral triangle gave us this, like the bottom was 60 degrees, that was 30 degrees. This was 1 because we chopped it in half. That's 2, and that was root 3. So look at these numbers, root 3 and 2. We're dealing with this triangle. I know in the other one, the ratios were 1, 1, and root 2. So if I saw those numbers, I would think, okay, it's the 45, 45, 90 triangle. So that's why you need to know your special triangles well. Now that we know this, I look at this and I'm thinking backwards. Okay, so which angle, 30 or 60 degrees, has root 3 as its opposite? And we can see that if we look at the 60 degrees down here, root 3 is opposite to that. So it must be the sine of 60 degrees that has, well, I guess that is my answer. I could say theta equals, oh my gosh, what am I doing? Theta equals 60 degrees. And 2 obviously is the hypotenuse, which we can see right here. So the answer after going through that would be 60 degrees. And if we want to think of that in radians, I did the radians in this teal color. that is the same thing as pi over 3. That is the same thing as pi over 6. So I would say or pi over 3. And this would be my answer after working my way through that. Okay, but maybe I should take it out of the box because let's put things into perspective. We found that the reference angle, I shouldn't say theta, I apologize. So we know that we got 60 degrees. That's for our reference angle. So I hope that that makes sense and I didn't just mess you up by doing that. But we found basically this little theta that's in here on our unit circle, but we're looking for the smallest positive angle. So do you see that we just found this theta is equal to 60 degrees or pi over 3, but what we want is the whole thing, that plus that. So in order to get our answer, we need to do a few other steps here. So for the 60 degrees, I would need to add 180 degrees plus the 60 degrees in order to get what it would be equal to. So that's 240 degrees is my theta. And similarly, I would want to do, well, the pi would be like 3 pi over 3 plus pi over 3. Why did I do that? Okay, so on the unit circle up here, if I found my theta was pi over 3, I would want to also add this, which would be, it's just pi, but that's the same thing as 3 pi over 3 when I think in terms of fractions. So this is just pi, but as a fraction over 3, it's 3 pi over 3. So I would get 4 pi over 3. So actually, theta is equal to this is my final answer. Okay, so I hope that you found this helpful. I'm going to get you to do the same page, so we're still doing 6.3, and this time you've done 1 to 4. You should have done the odd letters already for 1 to 4, and so you can do numbers 5, 7, and 11. You can do the odd letters. Actually, I'm going to say for all of these, you can do odd letters. And for numbers 6 and 8 to 10, I apologize. Let's just do odd letters for all of them because I get that this has been tough. So 5 to 15, just do the odd letters for the ones that have odd letters. For the ones that they're word problems, you can just do the whole thing. Okay, I hope you found that helpful.